morning, fifth graders. It's Mr. Slappy again with another lesson. Today's lesson we are going to be covering 5.MBT.2.6, which is find whole number quotients of whole numbers with up to 4-digit dividends and 2-digit divisor. So it looks like we're going back again because by this time we would have been at least reviewing for the FSA. So all your teachers in every single school would have been repeating these lessons so that you guys got as much practice as possible. So this is more or less a review on how to divide up to 2-digit divisors. So today's strategy that we're going to use is a strategy that's called partial quotient. And so the strategy partial quotient is just one of several ways we can solve large division problems. So with partial quotients, we actually begin by subtracting multiples of the divisor from the dividend. And then we just keep subtracting smaller multiples of the divisor until the remaining number is less than the divisor or 0. All right, so that being said, when we're talking about using multiples, the easiest partial quotient to use are usually multiples of 10. So that means 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So therefore, just by me saying that, that's what we're going to be multiplying our divisor by. Anything actually that has a pattern of a 0, like again, 10 has a 0 in it, 20 has a 0 in it, and then we're going to multiply those numbers by our divisor. So that way, it'll get us as close to our dividend as possible, and therefore we're going to actually subtract from that. So let's go ahead and get started. So I'm going to go ahead and erase this so that I can have as much room on my board as possible. So my first problem I'm going to divide is, to keep it simple, is 714 divided by 21. All right, so again, the easiest partial quotients to use are usually multiples of 10. So then we will add all our multiples to find the full quotient in the end. So again, so if I'm saying to you, I'm going to use multiples of 10, I'm going to actually multiply 21 times a multiple of 10. So and please follow along, because as I'm doing this, I'm going to keep track of what I'm subtracting or multiplying. So I'm going to use a multiple starting off with 10, 21 times 10, because it's easier to multiply this because 21 times 1 equals 21, and I have 1 0. And then I like to do this. I like to draw a line completely across to include the multiple that I'm using to multiply my divisor by. Then I simply, just like regular division, I'm going to subtract 504. So I'm not finished yet, because I remember, in division, we keep subtracting smaller multiples of the divisor until the remaining number is less than the divisor or 0. 504. So now I can ask myself this question again. Well, 21 times what can get me 504? Well, I used before multiple 10 So, and that got me 210. So therefore, I can use 21 times 10 again. Which gives me 210. Again, to keep track. 4 minus 0. Regroup. $294. Again, 21 times 10, because I need to continue to subtract until this number is less than my divisor or 0. So I can use 10 again. 21 times 10, 210. Again, 84. So far, the remainder is still not less than my divisor, so that's telling me that I can continue. But here, I cannot multiply 21 times 10 again, because then that would be too much. But what can I use instead? Here, now, 21 times 4. Because 21 times 4 will give me 84. With a remainder of 0. Now, how do I figure out what my quotient is? So again, the quotient is the answer to a division problem. So I kept track of all of the multiples that I use. So I use multiples of 10 and this 4. So I just simply add all of these up. 10 plus this 10 plus this 10 plus this 4. When I add all these up, I get 34. So if I were to write this properly, remember I'm lining everything up by place value, 34. This 3 needs to go in my tens place. This 4 needs to go in my ones place. All right, so that's my first example that I wanted to show you. But what happens when you use a number too large? What happens to a number when we use a number that's too large? So rewriting the problem, 714. So let's say if I decided to say, okay, wait, let me see if I can use, instead of 10, because I want to get as close to 714 as possible, let's say I use 100. Say 21 times 100. Well, I know that 21 times 1 equals 21. 2 zeros will give me 2,100. Well, what do we see right now the problem is? Am I able to subtract this as it stands? Well, as we know in subtraction, this bottom number is larger than our top number. That wouldn't be a problem other than this. I'm subtracting 2,100 from 714. I have nothing to regroup from over here. I don't have this. This only goes to the hundreds, not the 10,000s, which I need to regroup from. So therefore, this is too big. Can't use 100. That's why I use 10. Now let's see another example of other using the same problems, remember, I can use multiples of 10 to any multiples of 10. So that'd be 10 times 2, 10 times 3, which is 40, 10 times 5, it's 50. So I can use any of those numbers to get as close to 714 as possible. So let's use something different. So let's say, using the same strategy as partial quotient, instead of using 10, let's say I use a multiple of 21 times 2, which, all right, or 10 times 2, which gives me 20. So if I'm using 10 times 2, which gives me 20, so therefore 20 is a multiple of 10 and 2. So let's say I use 20 instead. Well, I can do that math quickly in my head. The reason why we like to use multiples, any multiples of 10, is because it has zeros in it, and we can pretty quickly multiply 21 times 2. Well, automatically I know that's 21 doubles, that's 42. I have 1 0, which gives me 420. Subtract. I like to keep track. 4. This gives me a 6. 294. All right, so can I use 21 times 20 again? No, I can't use 21 times 20 again because 21 times 20 equals 420. Again, what can I use? Well, I can use, let's say, 21 times 10. Because remember, just as long as I'm not going over this number, I'm fine. 21 times 10 gives me 210. Again, I'm keeping track of what I'm using because I'm going to add these up later. 84. All right, so now 21 times what can get me 84 without going over? Now, here's where I want to show you just, I know that I can multiply 21 times 4, which is going to get me 84, but here's the thing. I can't go wrong if I'm using multiples, so I'm going to try something different. Let's try 21 times 2. The difference is that I just have to keep going again until my remaining number is less than the divisor, or 0. So if I use 2, which 21 times 2, that's doubled, gives me 42. Let me rewrite this because I want to keep this in line. Subtract. Well, 42, is this number less than my divisor? No, it's not. So I know again that I can use 2 again. This gives me 42. Remainder 0. Now, again, I just simply add 20 plus 10 plus this 2 plus this 2, 34. It's the same answer we got, but if you notice, we just use different multiples to multiply our divisor with. Again, just as long as we're using multiples, and if you're not going to go wrong. You're not going to go wrong. If you try 30, and if that was too much, then you know that I could drop down to 20. That's too much, I could drop down to 10. It makes it much easier if you're just using, again, patterns of 0. Anything with a 0 in it just makes it so much easier until you get to this point where you're just performing simple operations of 2-digit by 1-digit to figure out your quotient. All right, so I am going to give you a problem that you can, again, work out on your own, and you can then send that to your teacher and say, hey, I watched LX TV, and Mr. Slappy said we can send our answers or our questions and our answers to you. They could check it out and let them know that you use the strategy partial quotient, and your teacher should be able to walk you along the way. Or if you have difficulties, you can always reach out to your teacher on Teams and say to them, hey, listen, I'm struggling with this question. Mr. Slappy's using that partial quotient strategy, so I'm kind of stuck. So here's a problem that I want you to work out, and I want you to use the partial quotient strategy if possible. So we're going to divide 522 by 18. All right, so again, remember my last hint that I'm going to use. I'm going to ask you, well, what can I multiply 18 by? It has a pattern of a 0 in it. And again, we're using multiples of 10. So I'll tell you what, I'll do you one better. I'll start you off. 18 times 10. Let's go with that. You don't have to use 10. You can use 20. You can use 30. Try it. All right, so until next time, I will see you later. Be safe out there. Bye.